Okay, so in this lesson we're going to solve quadratic equations by using the quadratic formula, and we'll call this part 2. Alright, so remember the standard form of a quadratic equation looks like this. Alright, so this is a standard form. So you have ax squared plus bx plus c equals 0. And so the quadratic formula, so if you want to find the solutions to this equation, to this quadratic equation, you can use the quadratic formula. Now my variable is x, I'm going to say x equal the opposite of b plus or minus the square root of, remember we call this discriminant, the radicand is called the discriminant, b squared minus 4ac all over 2 times a. Now remember, this discriminant will tell you how many solutions you're going to have, how many distinct solutions you're going to have, and the type of solutions that you will have. It's not going to tell you what the solutions are. You have to use this to determine what they are, but it'll tell you how many distinct solutions you'll have and the type. Okay, so let's look at this example. All right, number 1. Suppose you want to solve, remember you're solving each equation. So let's suppose we had x squared equal 3x plus 3. So x squared equal 3x plus 3. Now notice that this quadratic equation, x squared, this quadratic equation is not in standard form, so you need to put it in standard form. So if I put it in standard form, you bring all the terms to one side, and since the coefficient of x squared here is positive on the left-hand side, bring everything to the left. So I'm going to have x squared minus 3x minus 3 equals 0. Now the next thing you want to do is to denote what a, b, and c are. Denote the values of a, b, and c. So remember this right here. This quadratic formula. And so you want to identify the values of a, b, and c and then plug them back into this formula. Alright, so in this case, a is, remember, the coefficient of x squared, so that's 1. B is the coefficient of x, so that's negative 3. And C is your constant, and that's negative 3 as well. And so I'm going to take this and plug it back into the formula. So I get x equal the opposite of b. So if b is negative 3, the opposite of negative 3 is a positive 3. Plus or minus the square root of, and make sure you put those in parentheses. B is negative 3, but I'm squaring it. Now remember, whenever you square a number, this is always going to be positive. So b squared will be positive or 0. Minus 4 times a is 1, times c, which is negative 3. All over, okay, all that's being divided by 2 times a, and a is 1. All right, now let's simplify as much as possible in the radicand. So I get 3 plus or minus the square root of negative 3 squared is a positive 9. Alright, a negative times a positive times a negative is a positive, so I'm going to get 9 plus a number. 4 times 1 times 3 is 12. All over 2 times 1, which is 2. Alright, and so 9 plus 12 is 21, so I get 3 plus or minus the square root of 21 over 2. And I cannot simplify the square root of 21. Other than 1, there's no other perfect square that goes into 21, so there's your answer. So in your blank, you'll say x equal 3 plus or minus the square root of 21 over 2. Or if you want to write it as two separate equations, you can say x equal 3 plus the square root of 21 over 2, comma, 3 minus the square root of 21 over 2. Right? And if you want to write them as two separate fractions, you can do that as well. So remember, all these are solutions. Now, in my math lab, they're going to tell you probably to separate your solutions using a comma. So you're going to have to write it like this. Now, if you want to write it as two separate equations, you can do that. So if you start here, you can say 3 divided by 2 plus or minus the square root of 21 divided by 2. So that's you can write it as this as well, or if you can write it as two separate solutions. Write them as fractions though. So you can say x equal 3 divided by 2 plus the square root of 21 divided by 2, x equal 3 divided by 2, minus the square root of 21 divided by 2. So all these are ways of writing the solution. All right, so that's number 1. Now notice that this is real. I'm sorry, that it is real. That these are real solutions, but this is irrational. I wanted to use the word irrational. You're still left with the square root in the solution, so that's an irrational number. There's no way you can write the square root of 21 as a over b, where a and b are integers. Okay, number 2. Suppose you had x squared plus 5 equal x squared plus 5 equal negative 5x. Alright, first thing you got to do is make sure you put it in standard form. So I'm going to put this in standard form. I'm going to get x squared plus 5x plus 5 equals 0. So put it in descending order. Then remember the next step is to identify a, b, and c. So a in this case is the coefficient of x squared, which is 1. b is the coefficient of x, which is a positive 5. And c is your constant, which is a positive 5 also. And so we plug it back into the formula. We're going to get x equal the opposite of b. So b is 5. The opposite of 5 is a negative 5. Plus or minus the square root of b, put it in parentheses, which is 5, and I'm squaring it, minus 4 times a is 1, times c, which is 5, all over 2 times a, so that's 2 times 1. So I get negative 5, plus or minus, all right, the square root of 5 squared is 25. Negative times a positive is a negative. 4 times 5 is 20. All over 2. So I get negative 5 plus or minus the square root of 5. 5 minus 20 is 5. Let me write this. Negative 5 plus or minus the square root of 5 all over 2. So you can write your answer like this. And remember, this is irrational. You have the square root in the answer. Again, you can write them in all those separate ways. All right, but this is more the compact form that you would see. Okay, number 3. Suppose you had 2n squared plus 5n minus 9 equals 0. So 2n squared plus 5n minus 9 equals 0. So it's already in standard form, so let's determine what a, b, and c are. So a is the coefficient of n squared, so that's 2. B is the coefficient of n, so that's a positive 5. And c is your constant, so that's a negative 9. All right, plugging back into the formula, we're going to get n equals, make sure you use the correct variable. So don't say x, because that's not an x. You got to say n. So n equal the opposite of b. So the opposite of b is a negative 5. Plus or minus, all right, do your discriminant, so b squared. So that's 5 squared minus 4 times a is 2, times c, which is a negative 9, all over 2 times a, and 2, so we get 2 times 2. So we get negative 5 plus or minus the square root of 5 squared is 25. A negative times a positive times a negative is a positive. 4 times 2 is 8. 8 times 9 is going to be 72, all over 4. So I get negative 5 plus or minus the square root of, that's going to be 97 divided by 4. And there is, if you take all of the perfect squares halfway up to 97, besides 1, no other perfect square will go into 97. So 4 will not go to 97 evenly. 9 will not go to 97 evenly. 16 will not go to 97 evenly. 25 will not go to 97 evenly. 36 will not go into 97 evenly. And then 49 will not go into 97 evenly. All right, so there's your answer right here. That's it. Now again, there are different ways of writing the answer. You can write it as two separate solutions like this. Negative 5 plus the square root of 97 over 4. Negative 5 minus the square root of 97 over 4. Alright, so that's another way of writing it. Now in my math lab, they're probably going to want you to separate the solutions like this. Or you could have rewritten it as two separate fractions. So you could have said x equal negative 5/4 plus the square root of 97 over 4, comma, negative 5/4 minus the square root of 97 over 4. Again, any of these is correct. All right, now let's talk about the discriminant again. So remember, your discriminant is that b squared minus 4ac. So if you look at number 2 right here, the discriminant was 5. Okay. If you look at number 1, the discriminant was 21. If you look at number 3, the discriminant is 97. The point being, if you go back to the previous lesson, where we had, let me look at an easier one, where we had something like 121. All right, so 121 is positive. 96. Okay, over here we did 97 is positive. All right, so that's going to give us the fact that the discriminant is positive. Okay, so I'm going to write this down. B squared minus 4ac is positive. All right, so that means I'm going to get two different real solutions. Okay, now let's kind of talk about the previous lesson. This positive number was a perfect square. So remember, if the discriminant is a perfect square, you're going to end up with rational solutions. So that's why it looked like this. All right, so if you go back to the video where we did all these, you'll notice that your rational solutions look like this. In this case, remember, your discriminant was 0, so you ended up with one solution. Over here, notice the discriminant is a perfect square, so you ended up with two rational solutions that look like this. Okay, so if the discriminant is positive, you're going to get two distinct real solutions. But if it's not a perfect square, see how this is not a perfect square, 97 is not a perfect square, since b squared minus 4ac is not a perfect square, we get two different irrational solutions. Okay, so they're going to be irrational. The previous lesson, they were rational. In this case, they are irrational. So notice how it looks compared to the previous one. Okay? All right, let's look at number 4. All right, number 4, we have 4x squared minus 2x minus 5 equal 0. All right, so it's already in standard form. So let's just determine what a, b, and c are. So a is 4, b is negative 2, c is negative 5. So remember, a is the coefficient of x squared, so that's 4. B is the coefficient of x, so that's negative 2. And c is the constant, so that's negative 5. Now remember, though, you got to remember this is negative. You got to make sure that this is in standard form, and it already is. All right, so then we're going to plug in these numbers into the formula. So I get x equal the opposite of b. So remember, the quadratic formula says the opposite of b. So if b is negative 2, the opposite of a negative 2 is a positive 2. So that's what goes here. So you get 2 plus or minus the square root of, and then b squared minus 4ac. So I say b, which is negative 2, and I square it, minus 4 times a is 4, times c, which is negative 5, all over 2 times a, and a is 4. So that's where I'm at. So then simplifying the radicand, the discriminant of the radicand, I get 2 plus or minus the square root of negative 2 squared is 4. Remember, the b squared is always going to be positive or 0. So in this case, it's a positive 4. All right, a negative times a positive times a negative is a positive. So I got this will be 4 plus some number. 4, let's see, 4 times 5 is 20. And then 20 times 4 is 80. So this can be plus 80 right here, all over 8. 4 plus 80 is 84. So I get 2 plus or minus the square root of 84 over 8. All right, now make sure you simplify the radical if you can. And in this case, I can because the perfect square that goes into 84, well, 4 definitely goes into 84. All right, now, before I go on, let me mention this. So your discriminant is positive. It is not a perfect square, so you're going to end up with 2 distinct solutions, real solutions that are irrational. All right, so your discriminant is, in this case, it's 84. So that's greater than 0, 84. And since 84 is not a perfect square, I should get 2 distinct real solutions that are irrational. So in this case, meaning that in my answer, I'm going to get a square root. Okay, so let's simplify this. So that's going to be the square root of 4 times 21. And the square root of 4 is 2, so I get 2 square root of 21. So that's what I get. So that's going to go here. So I get 2 plus or minus 2 square root of 21 all over 8. All right, now, okay, so I want you to notice that if you left your answer like this, I mean, it's fine, but if it's set to simplify, all right, so simplifying here means simplify the radical. It also means simplify, reduce if you can. All right, so if you notice that this is a 2, this is a 2, and this is an 8, so those 3 numbers are divisible by 2. Okay, so I want you to notice 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1, so 1 square root of 21 is just square root of 21, divided by, and then 8 divided by 2 is 4. So that's the answer you would see. Okay? Now, let me mention this. If you want to go ahead and write this as 2 separate fractions, you can. Notice what happens. You get 2 eighths plus or minus 2 square root of 21 over 8, but then reduce. 2 eighths is 1/4, plus or minus, and then again 2 eighths. That's going to be 1/4, just like this. So you get square root of 21 over 4. All right, so that's another way of writing your solutions. But notice that this is really this. 1 divided by 4, see that? 1 divided by 4, 1 divided by 4, plus or minus square root of 21 divided by 4, which is what this is. All right, but if it says to simplify, not only are you simplifying the radical, but you're simplifying these parts if you can. So look at those numbers in the numerator and the denominator and see if those 3 numbers are divisible by another number other than 1. All right? Okay, so either one of those will be your answer. You can write them as 2 separate solutions. So you can say x equal 1 plus the square root of 21 over 4, comma 1 minus the square root of 21 over 4. All right, so either one's fine. Now remember, this is the answer because it's set to simplify. So again, simplify means to simplify the radical, and to also reduce. Okay. All right, number 5. Let's suppose we had this. We had x squared plus 10x minus 7 equals 0. So again, it's already in standard form. So a is 1, coefficient of x squared, so that's 1. B is coefficient of x, so that's 10. And c is your constant, so that's negative 7. And so we plug these three values back into the formula. So I get x equal the opposite of b, so the opposite of 10 is a negative 10, plus or minus the square root of b squared, so that's 10 squared, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, which is 1. So I get negative 10 plus or minus the square root of 10 squared is 100. A negative times a positive times a negative is a positive. 4 times 1 times 7 is 28, all over 2. 2 times 1 is 2. And then 100 plus 28 is 128, so I get negative 10 plus or minus the square root of 128 all over 2. All right, now let's simplify if we can. For this, I know that, I'm going to go down here, so I know this. I know that 4 goes into 128. I can see 4 goes into 12 and 4 goes into 8, so it goes to 128. So that's going to be 4 times 32. Okay? Now 4 is not the largest because I noticed that 32, right here, 32, I can write as 16 times 2. All right, and so the largest would have been 64, just to let you know. The largest would have been 64. So if you had used the largest, watch how simple this becomes. If you had used the largest, you would have said 64 times 2, and the square root of 64 is 8, so you get 8 square root of 2. All right, so that's where we'll go here. Now, if you had just used 4, okay, you would have done this. I'm just remind you. So you're going to have a little bit more steps to deal with versus if you had used the largest. So the square root of 4 is 2. So you get 2 square root of 32. But then you got to remember, not only does 4 go into 32, but also 16. So again, let's suppose you said, I'm going to use 4. All right. You should always use the largest, which in this case would be 16 if you use 32. Originally, though, the largest is 64. All right, so if you use 4, notice what happens. So notice all the steps. You're going to say 4 times 8. 4 times 8 is 32. So the square root of 4 is 2, so I get 2 times 2 square root of 8. But then you notice, all right, I can go further with square root of 8 because 4 also goes into 8. So I get 2 times the square root of 4 times 2. And then the square root of 4 is 2. So I get this. I get 2 times 2 times 2 square root of 2. And then this part here, 2 times 2 is 4. 4 times 2 is 8. So I get 8 square root of 30, square root of 2, which is what this was. So notice how many more steps you have to go through if you don't use the largest perfect square. All right, so let's go back over here now. So I'm going to get negative 10 plus or minus 8 square root of 2 over 2. All right, so just like we did in the previous one, remember this one right here. So remember, simplifying here means to simplify the radical, and it also means when you get to this point, can I reduce? Okay? So look at this. I simplified the radical. I got this. Now look at this right here. A negative 10, 8, and 2. They're all, I can reduce this because they're all divisible by 2. All right, so I'm going to get negative 10 divided by 2 is a negative 5, plus or minus 8 divided by 2 is 4, so you got 4 square root of 2, over 2 divided by 2 is 1. All right, but don't leave your hands like this because all this divided by 1 is the numerator. So you can say negative 5 plus or minus 4 square root of 2. And so there's your answer. So that's what x equals. Okay? Now, if you wanted to, let's say at this point here, let's say you wanted to break it down into 2 fractions. That's fine as well. Just make sure you reduce. So you would say negative 10 divided by 2 plus or minus 8 square root of 2 divided by 2. Now again, don't leave your answer like this because that's an 8 right here, because you want to reduce. So negative 10 divided by 2 is negative 5, plus or minus 4 divided by 2 is 4, and there's your answer again. So either one of those, you get the same answer. If you want to write them as two separate solutions, you can. So you'd say x equal negative 5 plus 4 square root of 2, comma, negative 5 minus 4 square root of 2. All right, so all of these are different ways of writing the solution. Just make sure if it says simplify that you know what that means. So simplify here is going to mean to simplify the radical, and also at some point check and see if you can reduce these numbers. Okay. All right, number 6. All right, let's do one more. All right, so let's suppose we had this instead. Suppose we had 6x squared minus 12x plus 1 equal 0. All right, so it's in standard form. A is 6, B is negative 12, and C is 1. So we plug that back into the formula, so I get x equal the opposite of negative 12. So if B is negative 12, the opposite of negative 12 is 12. Plus or minus the square root of B squared, so negative 12 squared, minus 4 times A times C, all over 2 times A, and A is 6. So I get 12 plus or minus the square root of, all right, negative 12 squared is 144. A negative times a positive is a negative, so you can be subtracting. 4 times 6 is 24, all over 12. So I get 12 plus or minus the square root of, all right, 144 minus 24 is 120 over 12. All right, now let's think about simplifying the square root of 120. Let's do that first. So square root of 120. So I know that 4 goes into 120. So I get 4 times 30. And there is no perfect square that will go into 30 other than 1. So the largest perfect square that goes into 120 is 4. So the square root of 4 is 2. So I get 2 square root of 30. And so that's going to go here. So I get 12 plus or minus 2 square root of 30 divided by 12. All right, now let's talk about how to write the answer. Now you see at this point, remember if it says to simplify, remember simplify means to simplify the radical, and also at this point, reduce if you can. Well, 12, 2, and 12, they have 2 in common. All right, so 12 divided by 2 is 6, plus or minus 2 divided by 2 is 1, so that's just square root of 30, over 12 divided by 2 is 6. All right, so you can leave your answer like this. Now, if you wanted to, at this point right here, you could have said 12 divided by 12 plus or minus 2 square root of 30 divided by 12, and then reduce. 12 divided by 12 is 1, plus or minus 2 divided by 12. Let's see, that's going to be 1, that's going to be 6 when you reduce. So you get the square root of 30 divided by 6. All right, so that's another way of writing the answer. If you want to write these as two separate solutions, you can. If you want to just go from here, you can say x equal 6 plus the square root of 30 over 6, comma, 6 minus the square root of 30 over 6. Or if you use this, you could have said this. Again, notice the different ways of writing the answer, the solutions. You could have said 1 plus the square root of 30 over 6, comma, 1 minus the square root of 30 over 6. So again, different ways of writing the answer. Okay? All right, so that's going to take care of part 2.